I can find the missing side of a triangle using similarity and proportions. So last time we proved triangles similar. This time we're told that they're similar. And knowing that, we know they're proportional. So we can use proportions to solve for the missing side. So this order is absolutely key. Notice how R corresponds to Q. Okay, so R corresponds to Q. In other words, RE corresponds to QG. So RE, I can put a little S for similar, corresponds to QG, I can put another little S. ET goes to GY, ET to GY, I could put two S's. And then we know this must be three S's. I do that for similarity, and I don't put ticks because they're not congruent, but they are similar or proportional to each other. Now, why is that helpful? Well, if you take a look here, we're trying to solve for x, which means we need to set up a proportion. I'll call this triangle 1 and triangle 2, so I know the sides are proportional. So for example, I need to pick a pair of sides that has the x in it because I'm looking for x. So I'm going to choose 21 and x. I'll go triangle 1 to triangle 2. Here I go. I'm going to say 21 from triangle 1 corresponds to x from triangle 2. And they have to be equal to, and it doesn't matter which one I pick. I can say 12 is to 8 or 18 is to 12. I'm going to go with the smaller ones. 12 is to 8. I could have put 18 is to 12. All three are supposed to be proportional, right? They should all reduce down to the same thing if they're going to be similar. So it does not matter. So now what I can do, I like to reduce first if I can. Makes things a little bit easier. 12 over 8, if I divide both by 4, that's really going to be 3 over 2. Now you can cross multiply. 3 times x is 3x. 21 times 2 is 42. Let's undo this multiplication of 3 with division of 3. And your x is looking to be, is that 15, 14, I think. 30, yep, 14. There we have it. That's how we solve for the missing side. You can try the same over here. Our find is y. So we're looking for it. Where is y? There it is. And you need to set up triangle 1, triangle 2. You can hit pause and try this one on your own. We're told already that they're similar, so they are proportional. And so I already know LU goes to SA, they correspond, so LU is similar to SA, okay? And then I know UH is similar to, is proportional, excuse me, to AP, they correspond. UH, I'll put two S's, AP, I'll put two S's, and so this must be 3 and 3. Very helpful for when I rotate or move around the other triangle. So if I zoom in on this one, let's set up our proportion. Let's pick something from triangle 1. Well, I want to make sure that I use the y. I want to solve for y. So I'm definitely going to include that. And y corresponds to, let's see, the AP. Okay, so y is to 4 as, and let's go with the 21. 21, again from triangle 1 to triangle 2. 3 and 3, there it is, to 6. I like to try and reduce first when I can. It makes things a little bit easier. Divide both by 3, I get 7 over 2. Now I can cross multiply. You could cross multiply first, but I find this easier. 2y, 28. Y is equal to 14. Okay. So again, when you're told they're similar, you're allowed to just set up a proportion. Make sure you pick the side that it has the unknown you're looking for, label your triangles 1 and 2, and if it helps you, use the order here with little S's on the sides to know which corresponds to which. If I come down here though, we have a composite figure. This is pretty challenging. Do you see the two triangles? There are two triangles there. So what we want to do is we want to take the small triangle and I'm going to put that right here. And then we want to take a look at the large triangle. and I'll put that right here. Now we need to be careful labeling, okay? So on my small triangle, this is 10, this is 12, this vertex is T, this vertex is L, this vertex is B. Okay, I took all of these and I put them right there. Now in the big blue one, this vertex is A, R, and B. That's interesting, they both have B. Huh. Come back to that. How long, though, is this blue side? And you need to be careful. Look at this 4, look at this 10. So the length of this entire blue side, if you use the segment addition postulate, is it's going to be 14. I did that by adding the 4 and the 10. Now this side over here is going to be 12 plus A. Don't say 12A. It's not 12 times A. It's 12 plus. You add them up to get the full length. Okay, now here's something else that was really, really important. I didn't tell you that these are similar triangles, the small green one and the big blue one. But we know that they are, and this is how. I know they both have angle B. It's in the green and the blue. And angle B is congruent to angle B. What's the reason why something is congruent to itself? You know it, the reflexive property. Angle B is congruent to angle B. So that's one pair of angles congruent. Now if we can just find one more angle pair congruent, we know these are similar by AA. And it turns out if we go back to the original, you see these parallel lines? Well, that allows us to do the following. I can extend that right there. Extend my lines a little bit. If I were to sketch that down here, you would notice when these lines are parallel that the corresponding angles, this angle and this angle, are congruent. And that's exactly what's congruent here. This angle and this angle. And they're corresponding. So you have this angle B is congruent to itself by the reflexive property, and then you have these two angles that are congruent to each other by corresponding angles when lines are parallel. So if I come over here, I can say angle BTL is congruent to angle TRA by the corresponding angles theorem. And so that allows me in my diagram to say these are congruent. I could also do the same thing over here for an L and A, their corresponding angles, and they're congruent when the lines are parallel, but I don't need to because I just need 2. So, therefore, I know that these are similar by angle-angle. So now I can set up a proportion, which is great. So I'm going to take these guys right here, and I'm going to go ahead and say, how about triangle 1 to triangle 2? And I'm going to say 10 is to 14, as 12 is to 12 plus A. Now I can reduce a little bit here, divide them both by 2. I end up getting 5 over 7. Might make this a little bit easier. Do not cross those 12s out. If this was times right here, you could, but you may absolutely not do that because the 12 is also being divided by the A being with that 12 in the denominator. So let's just go ahead and cross multiply. Now when you do, be careful. 5 times the quantity 12 plus A requires parentheses. 7 times 12 is 84. Let's go ahead and distribute, and you get 60 plus 5A is equal to 84. And now I'm going to solve it with my algebra skills. And it looks to me like my A is 24 over 5. A rational answer, which is just fine with me. It's not a big deal. Some will be integers, some will be rational, and that's okay. That's what A would have to be to keep the triangles proportional. There you have it. Make sure to resketch them as small and large. Set up your proportion, labeling triangles 1 and 2. Solve with cross multiplication in algebra. Keep in mind it's the reflexive property. Angle B is congruent to angle B, and corresponding angle theorem, because these are parallel, that allow us to say by angle-angle they are similar so we can actually set up the proportion, because similar means proportional. Good luck!